recording now because my thing got fixed. I'll be putting our notes back online if you want to see these notes. But distance and midpoint formula, again, you guys are responsible for that. Okay? You guys are responsible for knowing those two formulas. I've been giving you guys a lot of practice with the distance and midpoint formula. So please make sure you guys are responsible, making sure you know those two formulas. Those aren't going to go away. I was going to have today's short 2-question closing quiz on the distance and midpoint formula. But I'm going to say that for tomorrow because today's notes and assignment, you're going to get plenty of practice with distance and midpoint one more time. So that's going to be tomorrow. Tomorrow you have a quick distance and midpoint closing quiz. 2 questions, nothing fancy. All right. As you're checking again, back looking at your questions from yesterday, Friday. Let's get to talk on things. We are classifying again quadrilaterals, and as you look at some of those questions there, really on like number 3, we talked from first hour. Don't just assume things are happening unless you know for sure things are happening. And as we look at say number 3 right there, I'm going to zoom in just now a bit. With number 3. All sides being congruent. With all sides being congruent, we know for sure a rhombus has to be happening, but we don't know it's a square. In order for it to be a square, we have to be told that those adjacent sides are perpendicular. So just because all sides are congruent, it's still not enough information for it to become a square. Okay? In order for it to be a square, we have to have that additional piece of information. Adjacent sides are perpendicular. All right. Other things out there, C and E sound like, again, C and E sound like they are very similar. C is going, giving us a parallelogram. 2 opposite sides are parallel. What also falls into that? A rectangle does that. A rhombus does that. Actually, a square. They all do that. But there's not enough information that gives me other than a parallelogram. What does give me additional information now is like letter E. All sides are congruent. So then on E, by them telling us that additional piece of information that all sides are congruent, that makes it a rhombus. Not just a parallelogram, it makes it a rhombus. So again, don't just assume things are happening. You got to be knowing things are happening with that. I know we're kind of being a little picky on that, but that is the case on there. Last part of that page is where that's old school stuff, where we're writing the equation of a line. We've been doing that here. And then on the back side of things is where we're classifying the quadrilaterals. So I'm going to flip it. On the back side of that, we get those 2 quadrilaterals. Okay, as you guys are looking back through your homework from this weekend, anybody want to note? Sorry, anybody want a specific question on anything on the back side? This is your chance to look, ask, look at what you guys did this weekend. Again, if you're just writing down stuff to write down work, that does nothing. If you have a legitimate question, that's where we're at. Jay? 6A. That's a good one to talk about. First thing I did is when I made my answer key is I plotted out that picture. So 6A is what we're going to look at here. Negative 6, 3. And then what? Negative 2, 0. Negative 2, negative 5. And negative 6, negative 2. All right. So first thing I'm doing again is getting that visual out there. And 6A is asking about links. Okay? Those links start to narrow down what we got going. All right. On that one, I got my 2 easy ones. These are nice and vertical. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's where I get the length of DA and BC to be 5. So those are easy to count. But the other 2, they're not vertical or horizontal. That's where we talked about doing one of 2 things. Make the right triangle, or you could also use the distance formula. I went ahead and just used the Pythagorean theorem, the right triangle. And again, over the last couple of days, we said, hey, if you get a 3, 4, The hypotenuse will always be at 3, 4, 5. Okay, 3 squared plus 4 squared always going to work out to be a 5 squared. It's always going to turn out to be 5. So that turns out to be a 3, 4, 5. And what shape gives me a 5, 5, 5 all around? It's either a rhombus or a square. Now, I got 5s going all around. I don't know if it's a rhombus or a square out of which those two. Again, I don't know 100% sure on. So I got to look at the slopes. And that's where I'm at now. Yes, it looks like a rhombus. It does not look like a square, but we don't go based off of looks. If I take away your coordinate grid and you don't have that picture there, how do I know the difference between a rhombus and a square? It's all about the slopes. I'm looking at the slopes now. So I'm going to go ahead and, she only asked about A, I'm going to go ahead and do part B. So I always look at the slopes then. And that's what I did. I identified the 4 slopes then on part B. Look at those 4 sides, I looked at the slopes. The vertical ones are easy. Vertical ones, I did my rise over run. I got a 0, and anything divided by 0 is undefined. Vertical is always undefined. And then what I also did was, I got my slopes of the other 2, the negative ones. They're decreasing. Down 3, right 4. And when I did that, I got a negative 3/4, a negative 3/4. To be a square, we're looking for perpendicular. We're looking for opposite reciprocals. And that's sure not opposite reciprocals up there. Negative 3/4 is undefined. There's nothing going on about that. So we do not have ourselves a square. Best we can say is, it is a rhombus. And that explanation that's there, tell me why you chose a rhombus. First thing is, all sides are congruent. And then tell me why, again, we finish off with the rhombus. The adjacent sides are not perpendicular because there's no slopes that are opposite reciprocals. That makes it a complete one. If you just say all sides congruent, I'm going to still say, well, why it's not a square. Tell me why you chose not a square. Because I'm going to be that person there. I'm going to be that teacher still playing devil's advocate. Why are you choosing not a square? Make sure you incorporate both those pieces there. Okay. Good question on that one. Anything else you guys got? This is your chance to ask about. Okay, when you get ready to turn this in on Friday, several of you did not turn in day 2's assignment, which is fine. I told you again, day 2, take the time on it, check over your work. So when you get ready to walk it up, I'm expecting to have day 2 in there and day 3. If you did not turn in day 2, read day 2 and day 3. Make sure your name's on both of those. Throw in the basket, get your calculators out, and pass out the notes for today. Day 2 and day 3. Day 2 and day 3. Let's go plot out X and Y. So where's X located? Go put that on there. -4, 6. And where's 2 at? -2. Now what is that X and Y representing? It is representing the endpoints of a diameter, right? So do your best now to draw that circle. Draw it fast. I would say draw your circle fast. If you try to take your time and draw a circle slow, it doesn't usually turn out to be a nice circle. Grace, I think, just scared herself drawing a circle. Okay? It doesn't usually turn out to be very pretty anyway. Mine always comes out to be more egg shape. Okay, so go ahead and try to draw a circle. Yep. Or, yeah, that's why I say mine turns out to always be kind of more eggish shape. There you go. There's mine. Okay, but here's the thing about it. I like to have visuals, but quadrilaterals and triangles, they're not too bad. But with the circle, it's not really great for it. The best thing is really just let's go through and making sure we know what the vocabulary is. So, can you really identify where the center of the circle is using that? No, it's hard to identify maybe where the visual is of that circle. So let's think about this. You want to find where the center of that circle is. It's on the diameter, right? We know where the diameter, we know what the diameter of a circle is. At least I hope we do. The diameter of a circle, what does that mean? The diameter of a circle goes through the center, right? We all know that. So the diameter of the circle is going to contain the center. I can't visually just see it. How am I going to find it then? Can I suggest how we're going to find it?
You take the length and you cut it in half.
Okay, that's not a bad idea. That would be nice if we were like on a nice horizontal vertical. But are we on a nice horizontal vertical? Not quite. That's not a bad idea if we were, but we are not on that. So how about another idea? Anybody else have another idea how we can find the center of that circle? We came in and had our two formulas that are on the board. What's one of our formulas that we've been using? Distance formula. What's the other one? Midpoint formula. So let's think about that. Where is the center of the circle located? It's located smack dab in the middle of the circle, right? Okay. Which is the middle of the diameter, right? So isn't diameter just the middle point of the diameter? So what we're going to do then is go and use the midpoint formula to help us find out the center of that circle. We're going to use that midpoint formula then. Okay? So we do it. That's why I've been working with you guys the last couple days to know that midpoint formula and now to apply it. So go up there and use X and Y.
Did they introduce this on Thursday?
I don't remember which day. So now let's apply it. Just knowing the formula. So just know the formula there, Tyler. And then let's plug in -4 plus 2. That's what it starts off with. That's the X and X. -4 plus 2 divided by 2. And then for the Y's, Y plus Y divided by 2. That's it. Right? The midpoint formula wasn't anything major. And then just watch your arithmetic. What's -4 plus 2? -2, and -2 divided by 2 is -1, right? And then 6 plus -2 is 4. Yeah, 4 divided by 2 is 2. Let's go put the center out there. Where's -1, 2 at? Based off of your pretty circle there, would you say the center, the midpoint, eyeball it? Would you say that's about the center-ish? Maybe looking at your circle, would you say that's about your center there? Yeah, roughly. The visuals are not going to be great though. Circles are never great. Okay. All right, one down. Let's go find the length of the diameter. How are you gonna go find the length of the diameter now? How are you gonna find the length of the diameter? Times the original length. But do I know the original length though? So I gotta find the length though, right? So how am I gonna go find the length, guys? Did somebody say that? I'm gonna go do my other formula. I'm gonna go do my distance formula. So go do me my distance formula. So over the last few days, I've been asking you to make sure you know your distance formula and you can correctly calculate our distance correctly. So just plug it in the respective spots, and let's slowly work out the distance then. Okay. Does it matter which one we call x1, y1, x2, y2? No, it doesn't matter. So I'm going to go calculate me my distance. X minus x squared plus y minus y. Okay. Okay, nothing new here. I've given you plenty of practice with that. Now, if you've taken me up on that practice, it's a whole other question. All right, to the calculator we go. Now, on your calculator, when we've done this, I said, don't plug in the square root symbol. Okay? All right, parentheses, 2. Now, we can do it one of two ways. We're all smart people. We can just say, hey, what's 2 minus a -4 right there? 2 negatives make that a plus. Or you can type in 2 minus a -4. just whatever you do there, make sure you type it in correctly. 2 plus 4 squared plus what? -2 minus 6 squared. Whatever you do, you should be getting the same answer. And what did you get for an answer right there? Somebody get 100? If you're not getting 100, it means you don't know how to use a calculator. So let's learn how to use that calculator. Okay? But you should be getting the square root of 100, I believe, right? Now, you got 100, but now we're going to take the square root of that. So what's the length of that diameter? The diameter is what?
10.
10. So don't forget the square root of that. Students will always forget the square root of that. The square root of 100 is 10. If the square root of the diameter is 10, sorry, the square root of 100 is 10, what's the length of my radius then? Radius is 5. Don't forget our relationship where if the diameter is 10, the radius is half of that, the radius is 5. Okay? So the radius is only going from the center to the edge of that circle. The diameter goes from endpoint to endpoint through the circle, through the center of that circle. Okay? All right, so we're using those two things big time today. So let's flip it. Let's go to the next one. Now on the next side, all right, we have what now on the next side? The endpoints of the what? Radius, don't we? With the endpoints of the radius, here's what we got. Well, what does that mean with the radius? It means we have something like this. Okay, that's what we got. This time, here's what we got. We've got the center to the edge of the circle. We don't have the diameter. We've got the radius, so the center to the edge of the circle. So in that first part, the coordinates, it doesn't matter. We're not going to use the midpoint formula. Just pick one. Which one do you want to call the center? A or B? A or B? A, sure. I don't care. It doesn't really matter in this one, okay? Because if you called A the center, then B is going around it. Or if you call B the center, A is going around it. It's not going to change up the circle, is it? It's still going to be the same size of circle. So Anna, you said A, right? Fine by me. On the last one, we had to actually calculate the center. Because what did I give in the last one? The endpoints of the diameter. Okay? Still got to do the distance formula. Go do it. Still got to go do the distance formula. Go calculate me the distance between those 2 points there, guys. You're going to get a lot of practice still with that distance formula. This is why I'm going to hold off until that closing quiz tomorrow. Okay? So go find me that distance between those 2 points. You got to know that distance formula. If you've not been doing that practice on it, better do it by tomorrow. I'm not going to give you that formula or the midpoint formula. SAT doesn't, so I'm not either. Go to that calculator of yours. -1 minus 2 squared, and then what is it? 4 minus 0 squared. Somebody got what? Square root of 25. Okay. Square root of 25, which is correct, which is 5. Now, here's the thing. I see it all the time with students. When we say distance formula, a lot of students will start off by saying, hey, D for distance. But this is representing D for distance. Don't write this down. And this is what they say. Hey, D for distance, so therefore, this is what we just found. Is that what we just found actually, though? No, what did we just find actually? We just found the radius, right? So I don't mind you saying D for distance, but don't forget what you're finding. What are we actually just finding here? R for radius, and what did we have? R is 5, and the diameter is 10. Every time I go through and grade things, I'd say at least, I don't know, I'd say at least 15% of the kids do that dumb mistake. Okay? So they do everything right, but put those in the wrong spots. If you want to do deeper distance, that's fine, but that is not representing the diameter. It's representing the distance. Okay? All right. Last one here. Let's see what you guys know about your formulas. Okay, so we got diameter of a circle. This is going to lead us into tomorrow's work. Okay, we got the diameter of a circle. So from one endpoint to the other endpoint of a circle, going through the center, calculate the area. So my question to you is, anybody remember the area formula of a circle?
Something to do with pi.
It's definitely to do with pi.
Something times 2.
2 pi r, or it's got a 3.14, it's kind of in there. Okay, 2 pi r is Sabrina's suggestion. Okay, Sabrina, I'm going to hold off on that 2 pi r. So that's my circumference formula. Okay, we'll do circumference first, come back to area. Okay, we get the circumference of a circle we're going to find. Got to know your formulas. We talked to rectangle, base times height. We talked to square, which is side squared. And we've talked to triangle, which is 1/2 base times height. Now we're bringing in the circumference. So we're going to start with circumference as Sabrina. First off, circumference is walking around the circle. That's the perimeter. That's the distance around the circle. So if you go around the circle there, that's what we're doing. Okay. All right. So gotta know what the radius is. We're given the diameter. If the diameter is 10, the radius is 5. Let's plug it in and use our formula. Okay. Radius is 5. 2 times 5 takes us back to, well, 10 pi, right? 10 times pi. Now, let's talk about the formats, guys, just like we do with radical work over the first part of the school year. When it says exact, we said simplest radical form. Same thing here now, let's throw in pi. When we say exact and you got pi in your answer, I better see pi in your answer. In terms of pi means pi should still be there. Nothing with your calculator in terms of rounding. Now, when it says nearest tenth, okay, to your calculator as you go. Okay, you said 3.14 a second ago. That's usually what we use through middle school, is 3.14. For this time of the game, let's use your calculators. Let's use the pi key on your calculator, all right? So, where do you see the pi key at, anybody?
Second arrow.
Correct. It's on my exponent key. So if you see right above the division key, you see my exponent key. It's in blue. So if I hit second, my exponent key, 10 pi, just like with radicals, your calculator can't handle it. It's going to change it to that decimal then. So if you hit 10 pi, you get nearest tenth, rounded appropriately, just like we did with radical work. So in this instance, it's going to be 31.4 for our rounding. Now, let's talk about our units. We're talking about inches because circumference is just perimeter. Perimeter is 1 dimension. Okay? All right, so make sure you have the right formatting on that. You don't round until I tell you how to round. If I don't tell you how to round, you always keep it in exact. 3 root 2, 5 root 7, 10 pi. All right, let's go back upstairs to area of a circle. Okay, Sabrina, you remember the other formula out there?
Is it pi r squared?
That is my other formula for the circle. So pi r squared, what that's again calculating is, that's calculating all that surface inside of that circle, okay? That's when you start throwing all that pizza sauce on top of that circle, that's what that's calculating, okay? So, in this instance, still gotta know what the radius is. Well, we know what the radius is 5, right? What is pi, what is 5 squared? 25, right? So 5 squared is 25. Leave it in terms of pi. When I say the exact in terms of pi, that's what we want, 25 pi. Go to my calculator, nearest tenth. What is 25 pi? Yep, nearest tenth is 78.5. Get to know those calculators. Now we're area. Area, doesn't matter what it is, area is units squared. In this case, meters squared. Okay. All right, let's go last column there. We do it backwards. We've done problems already backwards. I've given you some areas backwards before. Area of a rectangle backwards, find the side length. And then we did Pythagorean theorems, now we diagonal. I gave you some area of the squares. Take it backwards, find me the perimeter of the square. Given the perimeter of the square, take it backwards, find me the area of the square. So we've done some of these already backwards. Now I want you to take this backwards. Hey, give you the circumference. What's the area? So, given the circumference, you're starting off with the circumference formula. What is that circumference formula? 2 pi r. Okay? You got to know which formula you're starting off with. Okay? You're starting off the circumference formula. What do you have? 30 pi. With that being the case, why do I have that 30 pi equals 2 pi r? What do I need to have? I want to calculate the area. If I want to calculate the area, what do I have to have? I have to have the radius. Everything's got to be with the radius. Okay? I don't know what the radius is. It starts off as the circumference. So, use your equation skills. What do we have to do to solve for r? How do I get rid of that 2 pi? It's attached by what operation? And what's the inverse of multiplication? Correct. So we're dividing by 2 pi. Pi's cancel, and you all know what 30 divided by 2 is. Correct. So that's what we're doing. What times 2 is giving me that 30? And you all could have said 15 quickly, but that's what's happening algebraically. Now that you know what the radius is 15, what is 15 squared? 225, right? Go back to that calculator of yours. That's the answer I want, 225 pi. That's my exact. What is 225 pi? Maybe 225 pi, 706.9. Okay. Meters, 706.9 meters squared. Okay. So take it backwards. If you're taking it backwards, you got to know what formula you start off with. Start off with the circumference formula. On the last one, what formula are we starting off with? We're starting off with what formula? Starting off with the area formula. Area is pi r squared. Let me write that a little bit better. Take it again, one more time, taking it backwards. What squared is giving you 144? Now this one is kind of nice to see because I gave you 144. You said 12 like that. But what again is happening here is algebraically, what we're doing then is you took the square root of it. What type of an equation is that? It's not linear. It is, oh, it's not exponential. We haven't talked exponentials. It's quadratic. Okay, we're using our quadratic skills to solve by square roots. Square 144 is that quick 12 you told me on it. Okay, now we get two solutions, but does it make sense to have a radius that is negative 12? No. Toss negative and keep 12. All right, all that work to say, hey, circumference formula, 2 pi r, 2 pi 12. 2 pi 12 is 24 pi, right? Units are feet. And for the last time we go, to the calculator. 24 pi is
75.4.
75.4. What we are, feet. Okay. Alrighty. So that's where we're gonna leave things at, guys. Starting the process today, leading into tomorrow with area improvement. Okay. All right. Oh, wrong button. All right. That's where I'm gonna